Hey everyone, welcome back to another BTLO Replay. Before I hand it over to Josh, who is going to step us through a lab today, I just wanted to say be sure to follow us on Twitter or join us on Discord to keep in touch with the BTLO community. All the links from this video will be in the description box below. Alright, now to hand over to Josh.
Hi everyone, in this video we're going to be taking a look at the drill down investigation on BTLO. It is a medium difficulty security operations investigation, and we can see the tools here on the left hand side are Splunk and VirusTotal. Jumping into the lab, the first thing I like to do is go and check out the details tab so I can understand the scenario, just to help us kind of scope our investigation, make sure that we're looking at the right things. So we can see here your organization doesn't use AWS. So when a threat hunter starts seeing connections to multiple EC2 instances, it's time to start hunting to understand what happened. So the information can be passed to the incident response team and indicators can be gathered for threat intelligence sharing. And at the bottom here, we've just got some instructions on how to get Splunk running and then how to actually start our searches. So I've already got Splunk running. All I did was open up a terminal on the bottom bar down here and then ran the command as provided. And we know that we need to open Firefox and go to localhost port 8000 to actually get to the Splunk GUI. And then at the bottom here, it says, when we start all of our search queries, we want to run index equals wildcard, which means it's going to search across every index. There is only one index, but it just makes things a bit easier for us. And we need to set the time frame to all time. So I'm going to open up Firefox. I've already got it loaded. We're going to go to the search and reporting app. And what we want to do is make sure we change this. There's been so many times where I haven't, and then I wonder where all the data is. So click this, other, all time. And then we're going to run our search. Well, we're going to put this in. We're not going to run it yet. Because what this is going to do is this is going to run through every single log that's in this data set. And from what I remember, it has millions and millions of events. So we don't want to run this just yet. We want to take a look at the questions so we can see how we can scope this search to make sure it's not going to run for about 7 hours. So question 1, Wayne Corp Inc. doesn't use Amazon Web Services. Okay, so this is all the stuff that we got from the scenario text anyway. And we can see here, using sysmon logs, how many destination host names are found. Cool, so we now know that we want to scope it to sysmon logs, which is going to cut down our search significantly because we're not looking across every log source. We're just looking for sysmon, which is really useful. And I think we're just going to start with this question and then we'll look at the others afterwards. So sysmon logs, cool. So what I want to do first is to make sure that we're looking at the right source type, log source, sorry, is that I want to run some event sampling. I'm going to set this to 1 to 100. And what this means is that every 100 events there are, it's going to pull out one of them. So I am going to be missing 99 out of 100 events. But at the moment, that doesn't really bother me because I just want to do a high-level search to see what data we have. And then we can pivot off of that data from there and then remove the event sampling so we're actually looking at all of the logs just so we don't miss anything. So 1 to 100, index equals wildcard. I'm going to press enter and the search is going to start to run. So what we are looking for is this source type field here. Click on this, we can see all the different source types we have. So we've got things like FortiGate, Windows event logs, Suricata, IDS logs. These are sysmon, I believe. FortiGate Unified Threat Management, I think that is. And some streams as well. So we're going to let that load for a couple more seconds. What we're going to be looking at is either Win Event Log or XML Win Event Log. I can't actually remember off the top of my head which one is sysmon, so we can check both of them out. It's not a problem. And then the question was asking us to find how many destination host names are found. So destination host names, we can probably get that as an interesting field. So if we scroll down here, we've gone past D. Let's have a look what we've got. Destination IP potentially could be that. I don't see any destination host name, but that could just be because our search is still running, right? So we're not going to have all the data we need yet. And obviously we have the event sampling on. So the first thing I'm going to do is I'm going to go to source type. I'm going to filter on, let's try XML Win Event Log first, and we can see what we get from this search. And because we're focused on one source type, we're not looking at all of the data. We can actually reduce the event sampling as well. I'm going to leave this as it is for now. Yeah, here we go. So Windows sysmon is the provider name. So this is what we want to look at, this source type here. And we can see here we've got the interesting fields, destination hostname, perfect. So I'm going to turn the event sampling off because we want to make sure that we get every hostname. So no event sampling. And it's going to load, and we're just going to click on destination hostname, and we're just going to see what comes up. Now, obviously, we're going to get a lot of different hostnames in here, but we're only interested in EC2s. So we can see here, yeah, how many destination hostnames are found, number of destination EC2s. So we are going to need to let this complete because we want to make sure that we don't miss any. But we can start looking through this. We've got a lot of Akamai stuff, which is all just CDN. What we could potentially do is we could pivot on the names. We've got a lot of stuff for this server here, which is interesting. Cool, this is still running. Hopefully it shouldn't take too long. But while that's running, we're just going to take a look at question 2 because it seems like it's related. So enter the host names in the order of event count. Yeah, so we definitely want this search to fully complete just to make sure that we get an accurate answer for this question. And we need to submit the host names. Cool. And then question 3 is not really relevant to what we're doing right now, so we'll just focus on these first 2 questions for the moment. If we go back to destination hostname, which has helpfully disappeared. Where has it gone? Destination hostname. Let's get rid of this for a second. Destination hostname. Okay, so we don't see anything related to EC2s just yet because we typically see, and it mentions it in the question as well, .compute1.amazon.aws.com. So we're going to see that after the hostname. And we can't see any of those just yet. We've got these internal servers that we can see. So the WE number SRV. We've got some OneDrive stuff, more Akamai stuff. Nothing overly interesting and not what we're actually looking for yet. So what we can actually do is, because we know the format that these host names come in, is we can actually just adjust our search. We want to do destination hostname equals wildcard, so anything, and then we can just do .compute. And we're going to do we want to do a wildcard after that as well. Let's minimize this and wait for something to pop up, hopefully. If not, there's a couple other ways that we could try and do this. Okay, so there's one. Destination host name we can see here. There we go, we've got one of the EC2s there. And if we click on destination host name, we can actually see them pop up. So we've got one so far. See if any others come in. Okay, just the one so far. That will populate. Obviously, there's a lot of logs that Splunk has to go to help us get this information. But we can take a look at this, right, just to see what's going on. So we can see here data name, source host name. This is one of the internal servers, right? WE serve at waynecorpinc.local. We can see that it's actually connecting out to this EC2 here on this IP address. It's interesting that we can see our internal servers making connections, which is what we were told about in the scenario text for the investigation. So we can actually confirm that activity is happening. Is there anything else that's interesting in here? Be good to know what the destination port is as well. 443, so that's web traffic, HTTPS. I'm sure that's going to be relevant later on. We can see we've got 2 now. So in destination hostname, we've got 2. So it'd be good to see if there are any more. It's interesting that this one has 99 and this one only has 2 so far, but obviously that could change as we get through the data. We shouldn't have too much longer left on this search. So we'll go back to the question. How many destination host names? Okay, so we've got 2 so far. And for this one, we need to make sure we have all of them. There we go, we've got 3. Okay. Now we can tell when the search is actually complete because we're going to get a green tick up here. So we are just waiting for that now just to make sure we haven't missed anything. Especially because this EC2 here only has 3 events so far. It means, you know, if we stopped it now and there's another EC2 that has maybe 1 event, then we're going to miss that. Or if we had event sampling on as well, even if it was 1 to 10 event sampling, and we had, you know, an EC2 that didn't have many events associated with it, we could actually miss that really, really easily, which is why it's so important to refine our search and then make sure event sampling is turned off. Okay, so we're just waiting for the search to finish. Let's have a look at some of these other questions just while we wait. Looking at the image, interesting field to see what files are initiating these connections. So we can actually take a look at that now. If we close this, so we're looking for the image field in here. Okay, so we've got the tick. So we'll come back to question 3. We've got the tick. This is all of the data for this search. So if we go to destination host name, we can see we have 3 EC2s. So if we go back to questions, how many EC2s are found? 3. We've got that one. And then question 2, enter the host names in the order of event count with the highest first. So we can see here that this one has 87% of the events. So, and we don't want to include the dot compute. So we can just do EC2 23, 22, 63, 114. Whoa, pressing the wrong key there. EC2 23, 22, 63, 114. Comma space, EC2, and then it's 184, 72, 234, 184, and then the last one is EC2, 52, 70, 175, 181. Cool, okay, so we now know that our organization is communicating outbound to 3 Amazon Web Services virtual machines. We don't use AWS, we shouldn't be seeing this at all, so it's definitely suspicious. And what we need to do now is look at the interesting field image. So if we go on the left here, we find image. Cool, we can see there are 5 different results. Which files initiate these connections? Okay, so these are the 5 kind of files that are actually kicking off these connections. What is the image value of the lowest count? So we can see that we've got this, whatever this is, 3791.exe has initiated 1 connection. And the question is asking us for that. So we're going to put in c/inetpub root joomla 3791.exe. Cool. Question 4, what is the hostname and internal IP of the system that initiated this connection? So it must be referring to this single connection from this executable. So we can just click on this and it's going to add it to our search. And then we're going to see 1 result come back. Perfect. And then we want to know what the host name and internal IP is. So we can see the host name is this computer, unless the host name is a different value, but it should just be that. Unless we, yes, okay, yeah, here we go. It's the same thing, source host name. And then we want the source IP. So we can grab these 2 out. What does the question want first? I think it was the host name. Yeah, the host name. So we're going to copy all of this. It hasn't told us to use a specific format. It might want us to actually cut off the domain, but we can see if this works. So this, comma space, and then the IP is this. Oh, if we get this away, is this 192 address here. Paste that, see if it works. Yeah, perfect. On to question 5. What time was this connection event? Use the time created system time. Okay, so let's have a look in here. We can just do time, control F, so time. Is it going to highlight anything for us? It is. Oh, we've got a system time here. Yeah, this is what it wants. So we can just grab this value. So it's in 2016. Make sure it follows the format, year, month. Yeah, perfect. So we'll just take away these and submit. Okay, it's wrong. Okay, interesting. So let's look at the format. it wants hour, minute, minute, second, second. So hour, minute, minute, second, second. So it doesn't want the milliseconds. Get rid of that. Perfect. Question 6. What is the destination hostname and IP address of the AWS EC2 instance? So we want to go back up to the log. We want the hostname and IP, same as before. So destination hostname is this. Copy that. And then we want the destination IP, which is this. Nice and easy. Paste. Let's see if this works. Perfect. Cool. On to question 7 already. This is actually going quite quickly. Utilize sysmon logs to find the SHA-256 hash of the executable making this connection. Okay, so we know in this case, when we look at the image fields, the value is this 3791.exe. Now we've already added that to our search, and we want to work out the SHA-256 hash. Okay, interesting. And it did tell us to continue using sysmon. Yeah, so we still want to use sysmon, and we want to work out the hash of this. I don't believe it's in this log. I didn't see any hash fields anywhere. No. Okay, interesting. So we need to try and figure out the hash using sysmon and using this executable. So let's try and cut down this. Actually, so we know it's 3791.exe. Let's copy this. We're going to remove this. We're going to do 3791.exe. So this is just, we're not actually specifying any field. We're just doing a broad search for 3791.exe. I'm going to remove destination hostname. So we're just focusing on sysmon and where this string is present, 3791.exe. Let's run a search and see if anything comes back. Okay, we've got 69 events. So we've got a lot more to work with now. It's quite interesting. And what we can do is we can look through the interesting fields to see if there's any kind of hash field. I don't see any. Oh, hashes, okay. So we've got the SHA-1. What we want is SHA-256. Let's see if we can find that in here. What we could do is, if we just add one of these, if we just left click it, it'll add it to our search. And what we can do is, if we just remove all of this because we don't care about it, and then we do SHA-256 wildcard, and then close that off, it should help us find. No? Okay, it's not going to be as simple as that, of course. Okay, let's just go back to where we were. That hashes field definitely sounds like it's going to be where we're going to find the SHA-256. Parent command line. Let's have a look at the image field to see what is kicking this off. So we've got 3791.exe here, CMD and conhost. I mean, we can try and filter back on this, because this is the specific executable image. Oh, there we go. Look, we can see SHA-256, which is again within that hashes field. We can see the value here, SHA-256. Let's just make sure it's the same. Okay, so we are getting different ones, which is interesting. So this is the executable, right? But it is doing an image load for user env.dll. So the hash is probably going to be of this. So that's why all of these are different, right? Because we've got prof API DLL, then the hashes. We've got user env DLL, then the hashes. So this isn't actually giving us the hash of the executable that we want. So it's not overly helpful. I just want to keep digging through these. I mean, all of these, yeah, the same thing. So maybe this isn't where we want to look. What we could do is maybe look at image loaded. Is this exe? So if we go back here, we want to look at image loaded 53. Okay, we can see this here. Image loaded is the 3791.exe that we're actually looking for. We can confirm this. So image loaded is 3791, and we've got the hashes here. So this should be the hash of the executable that we're actually interested in. So if we grab this hash, where does it end? Here. Yep. We'll copy this, go to questions, and then we will put the hash in. Perfect, there we go, we've got it, cool. So question 8, search the hash online to find more about its reputation. On the behavior tab, look at the results for Microsoft System Internals. What two IPv4 addresses begin with 23.216? So let's open up VirusTotal. We're going to post this into the search tab. Yep. Okay, so again, we've confirmed it's malicious, right? We've got a lot of stuff saying it's all different things. There's not really a consistent. Cool, so we can see here, yeah, it's being reported for all different things. There doesn't seem to be one thing that everybody's flagging on. And then we wanted to look at the behavior tab. And then it mentioned Microsoft Sys internals, so we need to try and find out where that is on this page. It might just be easier if we just do Control F for Sys internals. Okay, not that, not that. Okay, interesting. Maybe we click on this. Okay, this is showing us the results, so this should be good. So we can see IP traffic. Now remember, we were looking for IPs that begin with 232.1.6. We can see here we got two that begin with this. We've got the port of 443. So let's just double check if it wants the port or not. Nope, just the IPs. So we'll copy this. We'll paste that. Does it in specific order? No, cool. So we'll just grab that one, and then we'll grab the second one here. And that is that question answered. So number 9, using these two IPs, check to see if there's any activity from them in Splunk, which there might not be. What is the number of events per IP where the address is mentioned anywhere in a log? Okay, so we want to kind of stop looking at sysmon specifically because we want to look at any type of log, and we want to search for these two IPs. Now I'm going to run the search together, and we want to see if it's anywhere in a log, right? So it could be source, it could be destination. So it might just be better if we just do a really, really broad search where we just do get rid of all of that. Actually, we are going to do them one at a time. So we'll copy this, paste that in there. Okay, we're grabbing a hash. We're going to go to the clipboard, paste it into the clipboard, and then we can paste it in here. So we'll just do this, and then we want to see if there's any single event that mentions this IP or the second IP as well. So we are going to need to wait for this to run, and it's going to start kicking off. And because it is such a broad search, we're not scoping it to a log source. We're not scoping it to a field as well. This is a really, really broad search. 0 events. Okay, that's interesting. So that could either be an issue with our search, or it could be that there is actually 0 events. We haven't got sampling turned on. So let's just go and check the other IP, just to see if any results come back for this. Again, we're going to use the clipboard. Get rid of this. Okay, let's run this search. 0 results. Okay, so let's just double check that that the search isn't just not working. So if we just do 192.168.wildcard, and we'll just see if events do come up, because it could be an issue with our search. And okay, so we can see events, which means that the other searches were working, but there is no events at all for those IP addresses. Because we're not specifying a field, if we search for an IP address and it was in the source field, it would come up. If it was in a destination field, it would come up. And the question did mention that, where is it? If there's any activity, which there might not be. So we haven't seen any connections in any of our logs to or from those two 23.216 IPs. So we can put the counts as 0 and 0. Cool. Question 10, at what time was this file uploaded to the web server? So by this file, I'm going to assume we're still talking about 3791.exe, because we haven't really been told to look at any other files. And we want to look at an upload to a web server. We want to get the value from the timestamp field. Okay, so let's just do a broad search for 3791.exe, and we'll just kind of get every log that mentions that executable name in it. We can go from there. So we're looking for a file upload, which is interesting. So what source types have we got? We got the sysmon, Windows event logs, HTTP, could be that if it's a file upload, FortiGate and Suricata. So let's look at the HTTP first, see what comes up. And we have 2 events for this, so it's quite easy for us to look through. This is the client IP here. Okay. Oh, I take it back, it's a lot to look through actually. So we've got 200 OK. And it's talking to a Microsoft IIS server. We've got the date here, but there's nothing actually telling us that we've got a file upload. So we've got form data. Not overly interesting. Okay, we've got a post request. So it's posting to index.php. Nothing that's screaming file uploads. And then what is this here? This looks like a file here. Yeah, we can see. Okay, here we go. File name 3791. Let's just try and understand this a bit better. Okay. So it definitely looks like a file upload because we've got the file contents here. All of this. Again, we've got the Microsoft IIS server, which is interesting. Let's just scroll down and see if there's anything at the bottom. Okay. So we've got the source port of 49490. Okay. I mean, this definitely looks like an upload, but there's nothing that's kind of blatantly telling us it is. I mean, we can see a file is traveling over the network, and that file is the executable that we're investigating. Where was the IP address? So the destination IP is an internal machine. That's interesting. Let's go look at the wording of the question again. What time was the file uploaded to the web server? Okay. Now, where was that client IP we saw? Here we go. The 40.80 address. Now, did that appear here at all? No. It doesn't mean it's not related, but it just means that VirusTotal hasn't got a record of it. Okay. So what we're looking at here is we're looking at a HTTP post request. What we're trying to do is just trying to work out which direction the file is actually going. Because here the client is the external IP. And if we can find it again, the destination IP is an internal machine, but the internal machine could be the web server actually. So it could be an attacker pushing the file onto our web server, which would make sense. It's coming from, so the referrer is coming from imreallynotbatman.com. Okay, so I'm pretty happy that this is a upload. I just want to see the ports that are involved. So if we go here, if we look at the, where is it? Destination port is port 80. Okay, so it could be HTTP. Well, it is HTTP file upload. So I'm pretty confident that what we're looking at here is the actual upload of 3791exe, which is all of this data here. So we were asked for a timestamp, but we were asked for a specific one, which is the timestamp field. So that's this one here, timestamp. And we'll see what format it wants it in. Okay, so same as before, it wants the minute, second, but not anything after that. So we can delete anything after the dot. Click submit. Perfect, we found it. Okay, so number 11, what user agent was used to upload the file? Okay, so I mean we can look through this, but it's going to be easier if we go to the interesting fields and we look for user agent or something similar. Here we go, HTTP user agent. Cool, and does it want the full user agent, or does it want something specific? Yeah, full user agent. So we can just copy this and paste that into here. Great. And then number 12, what URI received the post request from the attacker in order to upload the file? So we did see some paths earlier. We can try and see if this is an interesting field rather than digging through the raw log payload itself. So if we have a look for URI, we don't see anything. Don't see anything. No, okay. What we can do is we can just dig through this manually. So I don't know if it will be in this log. There's the user agent we saw. Maybe it will be here then, actually. We got the request here to index PHP. It could be that, because remember, we're looking for a post request. So actually, I'm going to submit this as the URI because it's posting to this over HTTP. Pop that in here. Yeah, we've got 2 questions left, 13, 14. What is the source IP responsible for the initial access? So we did see that client IP earlier. It's potentially going to be that because that IP address is uploading that file, which presumably is then giving the attacker a foothold. So it would make sense that the client IP here is the source IP that's conducting the initial access through a file upload. So we'll try this. Perfect. And then we got to the last question. We need to understand if any of our network defenses have detected this activity or if we're completely blind. Use one of the retrieved indicators to search the logs to see if anything has flagged this file as being malicious. Provide any timestamp retrieved from a relevant event log. A relevant log to show evidence of some kind of alert. So we want to see if any of our tools have alerted on this at all. And it's going to be best to pivot on the file name again. So what we did see earlier is we saw some different log sources when we just did our basic search for the executable. So if we just go back and we go just for the executable and we look at source type. Now we did see Suricata and FortiGate, and these are both security tools. So we want to look at both of these. We'll start with FortiGate and we'll see what this single event is. So we can see here subtype virus, event type infected. It's a notice level event. Message file is infected. Okay, so we can see that FortiGate has detected this as a malicious file, which is really, really cool to see that we have some kind of evidence that our alerting does work. And then what has the question asked us for again? It wants the timestamp from a relevant log. Okay, so this log tells us that FortiGate did see it. It did alert us that it is malicious. We can see here the file name 3791.exe. Let's try and grab a timestamp. Oh, we've got one there, but it's a bit short. Let's see what format the question wants it in. Okay, it wants it in this. I don't see it appearing like that in the log. We might need to convert it to that ourselves. Yeah, we have the date here, we have the time here. So we can copy both of these. So this is the date we want at the start. Whoa. Funky, mouse doing funky things. Then we want a space, then we want the hour, minute, second, which is this. Cool, and there we go. We finished the investigation. Now, what I do want to do is go and check. So we looked at FortiGate, but I do want to go and check Suricata just to see what that tool saw as well, because we did see it had one event for this. Can we see here? Okay, all we can just see is the connection from that client IP, the 40.80 public IP address connecting to our web server on 192.168 over port 80. And it did see the file here, 3791. So it observed that connection happen and that transfer, but it hasn't actually created any kind of security alert informing us that it's malicious. It's just said, I've seen this connection, whereas FortiGate has said, I've seen this connection and the file is malicious. You guys should check it out. So it's good just to wrap that up by double checking But that's it. We've answered all 14 questions. This was a medium security operations. In my opinion, I guess it depends on your experience, but this was kind of one of the easier ones for me personally. It'd be good to know what you guys think. But we've got it wrapped up. We found out. In summary, if we just take a look at the scenario tab, so we've confirmed that some of our internal IPs have made connections outbound to EC2s, which have been associated with malware historically, which we found through VirusTotal. And we found that one of them actually managed to upload a file, 3791.exe, to our web server. And at this point, as the scenario says, right, we would pass this off to the IR team. They could start digging in. They could do malware analysis on what that executable is, what it does, and then what other actions the adversary took in our environment. But we've completed our job as the threat hunter to go ahead and find evidence of something that's suspicious by doing our hunt for outbound EC2.
Thanks for watching. Be sure to like and subscribe to never miss a video. In the meantime, remember to join us on Discord and tune in every Friday at 6 PM BST for BTLO Replay. Thanks guys, and see you all next time.